Hello, my name is Clark Evans. I'm here to introduce HypertextLiteral, a macro for the interpolation of HTML content. HypertextLiteral is heavily inspired by its JavaScript namesake and has found a home in the Pluto community as a way to display Julia values within HTML and JavaScript content. HypertextLiteral is useful for those building both static reports and interactive web experiences with Julia. Today I'd like to talk about some of the design trade-offs of this library, as well as some of the implementation details. The problem HypertextLiteral solves is escaping. For today, let's use a Pluto notebook, but little in this talk requires Pluto. Suppose we'd like to take a user-entered input and display it in bold. Here we use string interpolation to build our content. When Pluto sees a string value, it shows it quoted and properly escaped. To let Pluto know that this string could be sent directly to the browser for display, we can use the HTML wrapper. So we entered Hello World, and it's here in bold. Everything's good, or is it? This simple approach doesn't work when user content contains HTML. Here we have a script tag with a JavaScript call to the alert function. Failure to escape user content is the root cause of many security issues. HypertextLiteral addresses this challenge. The HTML macro permits string interpolation, performing necessary escaping. By changing out the HTML wrapper with the HTML macro, this user input is now displayed as content, bold as desired. In Pluto, if you wish to see the HTML that was generated, you could use withTerminal and the print function. So, how does HTML work? In Julia, macros receive a syntax expression and produce a block of code which Julia then compiles just ahead of time. Let's use our example template, which bolds a given string. As given by Julia to our macro, this expression includes three items: a string, a symbol, and a string. The strings represent literal content which we wish to pass along, unescaped. The symbol is a variable reference. With this input, the HTML macro produces a corresponding expression. This expression builds a result object, which reflects the input using bypass, content, and bypass. The bypass object wraps values that should be printed without escaping. The content function should return an object to be printed, and this printing would be escaped. For any object, the content function provides suitable representation to be printed as hypertext. For strings, symbols, integers, and floating point values, content simply returns the object itself. The printed output is then escaped. Any object that can be shown to text HTML is passed along without escaping. Therefore, the built-in HTML wrapper can be used to ensure a given value isn't further processed. Otherwise, if a content method isn't defined for a given type, a translation that surrounds the printed value with a span tag is generated. In this way, user-defined styles can provide relevant formatting. HypertextLiteral includes an HTML lexer, letting it know in which context an interpolated expression occurs. Consider a button that has a user-defined value and a title. HTML sees this string as having 5 parts. It knows that v occurs within an attribute value, and that title occurs within the element content. Like the content function, the attribute value function also returns an object suitable for printing. Generally, HypertextLiteral simply reproduces parts of the template found between interpolated values. An exception is made to support Boolean attributes. When the lexer identifies an interpolated attribute value without quotes, the attribute pair function is used for its translation. The default implementation of this function reproduces the attribute name with the value in single quotes. However, if the value is a Boolean, it has a special interpretation. In the case of a true value, the attribute name is reproduced with empty quotes. If it is false or nothing, the entire attribute is omitted. The lexer can also identify when it is inside a script tag. Notably, ampersand escaping is not indicated inside a script tag. Instead, the interpolated value must be scanned to ensure that it does not contain the end tag. But how should interpolation work in this context? After feedback with the community, we decided that Julia values should be converted as JavaScript values. However, there's an escape hatch. If an object can be shown as text JavaScript, no translation is provided. Similar to HTML, we provide a JavaScript wrapper for reproducing JavaScript fragments. While the conversion of Julia objects into JavaScript is automagic within a script tag, we decided not to be so clever within attributes. That said, the JS function that does this conversion can be used directly. Note there's 2 levels of conversion in this example. First, the string value is translated to JavaScript, and then this result is ampersand escaped. The implementation of HypertextLiteral is motivated by the HTML object from the built-in documentation utilities. The single argument version wraps an object so it can be shown to a text HTML display. The multiple argument version is more interesting. It returns a closure that takes an I/O for its input and prints each of its arguments. We take a similar approach. The HTML macro produces an expression that builds a closure. Our result object is similar. The difference lies in the use of an escape proxy, which handles ampersand escaping. When our result object is shown, the incoming I/O is wrapped with this escape proxy. Then the closure is activated to print the content. In this way, lacking any other intervention, content is always escaped. The bypass wrapper is one such intervention. It simply forwards the print operation to the underlying I/O. To explain this a bit further, let's go back to our opening example, where we display user-provided text in bold. We could simulate the macro's behavior by creating an escape proxy, wrapping an existing input-output object, and then printing the three parts of the interpolated string. The result is the same. Before we close, I'd like to mention the non-standard string literal. The minor gain in syntax convenience is overwhelmed by the inability to nest properly and the lack of syntax highlighting. Even so, it has one advantage that I see. You can use it to construct dynamically generated templates. This approach to HTML generation is performant. In the test directory of the project, there's a simple phone book benchmark with 13 companies having a dozen or so employees. By following the closure style promoted by Julia's documentation, the resulting templates are simply quite fast. There is online documentation for HypertextLiteral. The main page provides a translation reference for each of the primary contexts, element content, attribute value, and script tag. Moreover, each of these contexts have their own documentation section. I look forward to any thoughts or questions, and of course users and contributors are very welcome. Thank you.